we can very easily compare the friction forces. Remember, comparing, not the absolute value, comparing the friction forces by using magnetic repulsion. In this very simple illustration, I will show you that very easily we can compare the friction 1 and friction 2, or that is obviously the ratio between them using these magnetic forces. I have taken a small object, toy object with wheels, very less friction, and I am placing a magnet with clearly the north pole marked as red. I'll take another magnet, face the north pole that is red towards it, and we have to note down the distance when it just starts moving after 2-3 trials. That means we'll take the average. Yes, that is the distance where it moves. We have to measure it with the scale. Yes. Now I'll take another object, heavy friction. Again, magnet is there. This time the distance is very less because friction is more. I'm measuring directly. There it moves a little. Yes, like the 2-3 trials, and then we have to take the average of that particular distance. Of course, we have to keep the same magnets again. Look at that. In the case of wheels, I got 8 centimeters as the average, and in the second case, I got 2 centimeters as the average repulsion distance. With the well-known formula, that is F1 by F2 friction 1 friction 2 are inversely proportional to distances d2 square by d1 square. So on substituting the values of 2 and 16, 2 square by 8 square, that comes to 4 by 64, and that means it is 16 times. Friction coefficient in the second case is 16 times more than that of the first case. In this very simple way, we can compare the coefficient of frictions between two different surfaces. Of course, we will get that ratio of frictions.